Hi guys, welcome to this revision summary video looking at the atom and the periodic table. The aim for this video is to look at all the key things that you need to revise to get yourself ready for the exam. If you want to go into more detail on any particular part, I've put a link in the top right hand corner to the playlist which goes into each section of the video in more detail, including practice questions and the model answers for them. So this is just an overview. If you want more detail, have a look at the playlist in the top right hand corner. We're going to start off with the atom then. So what you need to be able to do is tell me where the subatomic particles are in the atom, what their charge and what their mass is. So if we start off with electrons, nice and simply, they go around in energy shells or orbitals. In your nucleus, which is the part in the centre, you have protons and you have your neutrons. Now that number, the number of protons and neutrons in the centre, that is your mass number. That is where most of the mass of the atom is. So on your periodic table, you will have two numbers. For example, 12 and 6 for carbon. That number at the top, the big number, is the mass number. So that is the number of protons and neutrons. Some periodic tables will have that number the other way around, but for the GCSE in the UK, the big number should always be up at the top. So we know the nucleus has protons and neutrons. What we now need to know is what the charge is. So you need to remember all protons are positive, all electrons are negative, and all neutrons are neutral. And then you need to know the mass. Now, we spoke about the fact that protons and neutrons make up the mass number, so they are the ones with the mass. So protons, we say they have a mass of 1. Electrons have no mass, so we can say 1 over 1835 if you want to be specific, or just 0. And then neutrons, as I said, have a mass of 1. So what you also need to be able to do is work out how many protons, neutrons and electrons any atom has. So the bottom number on our periodic table, or the small number if yours is different, is the number of protons. So the smallest number is always the number of protons. It's also, for any atom, the number of electrons. The mass number, as we said, is the protons and neutrons added together. We know the protons, therefore you can work out the neutrons. So you take the mass number and you take away the atomic number from it. In other words, take the little number from the big number. So for example, aluminium, we've got 27 protons and neutrons added together. The 13 at the bottom tells us our 13 protons and also our 13 electrons. So to work out our neutrons, it's 27, take away 13, which gives us 14 neutrons. The next section is going to have a look at electronic configuration. So how are those electrons arranged? So it's really important to remember that the electrons is the small number. So if I've got lithium here, it's the bottom number, so I have 3 electrons. Rule number 2, the first shell can only hold 2 electrons. Rule number 3, shells 2 and 3 can hold 8 electrons. You won't need to know past that, so just remember 2 for the first, 8 for everything else. So let's have a look at an example. So we're going to go with lithium on the right hand side. We know that 2 electrons can go in the first shell, that's our second rule. I have 3 electrons, so I'm going to put 2 in there. Now of my 3, I've used 2, so I've got 1 electron left. Now my second shell can hold 8, but I've only got 1, so I put 1 electron in. And that's my electronic configuration. If I wanted to write it, it would be 2.1. If we have a look at aluminium, so I have 13 electrons, it's the small number, 2 on the first shell. How many have I got left? 11. How many can go in the second shell? 8, so I can put 8 in there. 11 take away 8, how many have I got left? 3, so I've got 3 remaining, and they can go on my third shell. So my written electronic configuration would be 2.8.3. Now, this electronic configuration is very much linked to where the atom is on the periodic table. So rule number 4 is the number of electrons in the outer shell tells you the group that the element is in. So this one here, we've got 6 electrons in the outer shell, therefore it's in group 6. The number of shells also tells you what period it's in. So although I've got 3 shells drawn here, only 2 of them are occupied, therefore it is in period 2. Now the ideas about the atom haven't always been exactly the same. It's changed quite a lot. So what you need to know is how Dalton came up with the original ideas for the atom and what it's like now. So we start off with Dalton then. He thought that every single atom was indestructible. He thought there was nothing else inside them, and he also said that all elements were made up of the same type of atom. So we now know that that part is right. If you have an element, they are all the same. However, we now know that the atoms are not indestructible. They contain protons, neutrons and electrons. Now, the first person to figure out that Dalton wasn't exactly right was J.J. Thomson. So he did an investigation and found out the mass of rays leaving a glass tube was much, much lighter than atoms were meant to be. So this first of all proved that Dalton was wrong. Atoms aren't indestructible. There are smaller parts to them. And it helped to discover that electrons existed. He later described this as the plum pudding model, where the atom itself was a positive pudding and then it contained negative electrons, which is your plums. And then later on came Rutherford. Rutherford fired in 20,000 positive particles, so protons, alpha particles. He fired them into a gold sheet. Now, most of those went straight through. However, a few of them refracted and very, very few repelled. So what this proved is there was a nucleus, and that nucleus was tiny. Now, of course, today we know that the nucleus contains protons and neutrons, and we know electrons go around in shells in orbitals around the outside. Now, you'll have also noticed on your periodic table, there are elements that have unwhole numbers. So for example, chlorine, that's the most famous example, it has a relative atomic mass of 35.5. Now that relative atomic mass is the average mass of all the isotopes. So there are lots of different isotopes of chlorine, the two main ones being chlorine 35 and chlorine 37, of which there's 75% of chlorine 35 and 25% of chlorine 37. So the definition of an isotope is it's something that has the same number of protons, so both these chlorines down here have got 17 protons, but a different number of neutrons. The one on the left has 18 neutrons and the one on the right has 20 neutrons. The next thing you do need to be able to do, regardless of the paper you're sitting, is work out the relative atomic mass for an isotope. Now to do that, all you need to do is take the mass number, multiply it by the percentage of the isotope and divide by 100. You do that for all the isotopes and then you add them together. So for example, our chlorine atom, you take our 35, you multiply it by the 75%, so 35 times 75, and you divide it by 100. You do the same with chlorine 37, so 37 times by the percentage, which is 25, divide that by 100, then when you add all that together, it comes to 35.5. A nice and simple calculation as long as you can remember the two steps needed. Okay, we're on to the periodic table part of the video. So there are a few things that you need to know about the periodic table. Number one being metals are on the left of our zigzag here and non-metals are on the right, with the exception of hydrogen. Hydrogen is a non-metal, you just need to learn that one. You also need to know the names of the groups. So group 1 is your alkali metals, group 7 is your halogens, and group 0 at the end here is your noble gases. The rows going across are the periods, which show you the number of shells, remembering the group tells you the number of electrons in the outer shell. Now the first person to come up with the idea of putting the elements into a table was Dmitri Mendeleev. Now what he did in the first place was he put all the elements into groups based on their chemical properties. And then later on, he realised that they would go up in order of atomic weight. Now this wasn't always the case, and sometimes he needed to swap them round if they didn't actually fit the pattern. And if there was something that didn't match at all, he would leave gaps. The reason he did that is because there were undiscovered elements, ones that hadn't been found yet. Now there are some similarities between Mendeleev's periodic table and ours. Nice and simply, ours are still in groups based on properties. However, we now know that it goes up in order of atomic number, the small number. And then the final thing Mendeleev could do, when he left gaps, he would look at the elements above and below in the periodic table. So for example, if the element above had a melting point of 27 and the one below had 100 degrees, he would be able to predict the properties of the undiscovered elements. So he would go, right, okay, 27, 100, about halfway in between, and he'd predict it was around 70. And he was pretty close with most of his estimations. And that is everything you need to know for the atom topic. So if you want more detail than any of those parts, have a look at the playlist in the top right hand corner. Make sure you're prepared for your exam, and good luck! Hi guys, thanks for watching. If you enjoyed the video, please click on like down below. You can also subscribe to my channel, you can check out the latest video, and you can visit my website up above here. Bye now.